My name's Charlie. I work for CSC Robotics. We are a Hong Kong-based company founded in 2019. Our footprint into the UK was at Digital Construction Week, where Alan actually approached our stand and asked, approached me after to see if I would join this event. So really happy to be here. But I imagine none of you have actually heard of us yet. So fingers crossed, in a couple of years you'll know exactly who we are, and that means I've done a pretty good job. So today on the construction site, I know we like to think we've come a long way, and we really have with regards to technology, digital side of it, especially in the last kind of 20 years. But actually, when you get onto the sites, a lot of it's still very manual, it's very traditional, it's very high risk, it's very repetitive. A lot of that hasn't changed in the last 40, 50 years, and I think now we're in a position where you are seeing these new kind of robotic pilots on site, and especially in other parts of the world, there are things happening and people are taking note now. So it all ties into this kind of digital topic that we're talking about. I think even in the keynotes earlier, AI automation was very high up on the agenda. So as you can see, productivity in the office is boosting through ERPs, project management tools, all of these kind of digital systems. But actually, when you get onto the site, we're still very stagnant. We're still at about 1%. Health and safety is all about making the user safer in a better environment, and handle vibration. There's even more kind of technology monitoring that constantly in real time. So we still got to prioritise worker safety. Labour crisis is a newer one for the UK, and it's expected to worsen within the next couple of years, especially with age and availability of skilled labour. A lot of people are coming, to the end of their retiring from these labour-intensive jobs, and we just haven't got the workforce coming through to take on these repetitive kind of high-risk tasks. Unstable performance, a lot of the manual work is kind of based on trust of people doing the right thing at the right time. Increasing costs, things like net zero and things like that are really being pushed onto the contractors, just adding to their risk and essentially delaying projects, especially on the major projects that we're seeing like HS2 and things like that. The nature of injury, nobody really talks about it, but when things go wrong on site, it costs the contractor, it costs the client money. People take time off work, still need to be paid for. So nature of injury is a big one as well. So automation isn't about replacing people, it's about creating a safer, more predictable, data-driven environment. And the industry faces three linked challenges. Oh, shit, sorry. Sorry, this is the slide I'm reading off now. The industry faces three linked challenges, and these are the principles to frame our discussion today. So safety, speed, and smartness. Ken made a comment earlier about, years ago he heard that, why can't we make construction more like manufacturing? Everyone in the room, and me included, will say every single site is different, and we always incur new challenges on every single site we're on. But essentially, if you look at the productivity from a manufacturing point of view on the left there, when they've taken on automation, it has kind of skyrocketed, or at least brought a stable increase in their productivity margins. When it comes to injuries on site, construction is still the highest industry, with 35 recorded in 2024-2025. So why now? The industry's ready. Digital foundations are kind of in place. BIM adoption, CDEs, all of these things from the 2010 era. The groundwork has already been done. 2020 saw the data delivery and all the data being collected, which will drive kind of real-time kind of decisions on site, whether it's from concrete sensors or supply chain kind of data. It's all been given in real time. So rather than making decisions in hindsight, we're making them in real time, which is obviously saving us money. Now we're bringing the automation era, kind of 2025 onwards. It's not really the future of construction, but I think more just an upgrade on what we've been working on. Made a comment there, data has made it possible, robotics will make it real. So what automation looks like on site, a lot of you have seen things from the other side of the world or in different markets, but you've got task level automation where you've got the drilling, the welding, rebar tying, polishing. There's pretty much a solution for everything now, and now it's just about trying to make it fit on that job site. Process level automation from robotic layout, that's obviously been embedded in construction for years and years and years now, the HP site prints, Dusties, things like that. Then you've got system level automation, which is integrated digital twins. My man who spoke before, a bit more clued up on that side of it. But obviously the system level automation is really important, because as that advances, the robotics side will tie into those digital twins, and these decisions will be made in real time, and things will get a lot more efficient. So safer, it goes without saying that the big kind of benefit with automation is to be able to remove people from harm and remove people from hazardous tasks. Hand-on vibration is still a massive thing in the industry. I know we've been talking about it for a long time, and the upgrades to these tools that allow people to use these tools for an extra, 5 minutes a day, doesn't really protect them. So actually being able to remove them from those situations entirely is where we need to look at moving into the industry. Silica dust exposure, working at heights, still a massive thing into the industry as well. But yeah, automating tasks in confined spaces, and rather than having the worker actually doing those tasks themselves, keeping them into safe zones, they still will need to be involved in the robotic situation. Faster, so it goes without saying that robots don't need to take breaks like humans do. They don't need cigarettes. They don't need to go to the toilet. So the machines can work overnight if the sites allow you to. That's another thing, but they can. They don't fatigue. You essentially just change the battery on a lot of these projects. Reduce rework due to the precision layout and the QA automation. Predictable cycle time. So if you're drilling, a repetitive situation would be, and I'll talk about it in a minute, would be like a base plate application, M24 by 160. You've got 6,000 holes to do. We can tell you exactly how long it's taken. It's kind of recording every single hole. That means that application layout becomes predictable over the next days, weeks. Productivity, other side of the world now, I'm sure you've seen a lot of the stuff happening in China and Japan, Hong Kong, Singapore. Earthworks is a big thing where they've really pushed automation into their industry, and they're showing productivity gains of 30 to 50%. Smarter, every action produces the data that will feed into obviously the digital twin information as well. So the automatic data capture from, say, drones, robots, machine sensors, that will all feed into the system and then update in real time. So that is something that is going to really hyperscale this industry over the next 5 years and onwards. So a couple of case studies I've just got things that we're kind of working on at the moment rather than going into competitors. I'm not going to say competitors loosely because I don't think there really are competitors in this space at the moment. This is an automated car park in Hong Kong. It's a boundary crossing facility where, if people were going to the airport or going to sightseeing around Hong Kong, they would park their cars, leave it there for a couple of weeks. So it's an automated car park. Park the car, it moves where it needs to be. The application was heavy drilling, structural steel application. So the base plates, 1,500 base plates in total. Number of holes to drill was 6,000, and the drill size was 24 mil diameter and 135 mil depth. I haven't got any videos because we don't really have the time, but I've screenshot a couple of things here. But essentially, we automated this process with our DF, which is a floor drilling, fully autonomous floor drilling machine. So it will drill downwards into the floor, horizontally, and into ceiling applications. It does weigh around 500 kilos, so it's not something you can mount or integrate into a scissor lift and lift it. So there are obviously height restrictions of about 3 meters, depending on where the arm can go. The average drilling rate for a human was 3 to 4 minutes per hole, and that included marking, positioning, drilling, and minor repositioning. The robotic system was 1.5 to 2 minutes per hole, so it gave significant productivity gains on this. It's attached with LiDAR. The Revit kind of BIM model was uploaded into the document, so it knew exactly where to go. The base plate's dimensions are all the same, so the robot was taught to actually use that the calculations of the base plate and just really repetitive kind of marking and drilling. Another project we did was a water treatment plant in Hong Kong. Similar situation, drill bit size was 14 mil by 110. It was 800 holes. Time saving compared to a human operator was the DF robot took 10 hours and the manual was 20 to 26 hours. Project we did with Boyds in Hong Kong again. It was a T2 trunk tunnel, which is a bit of a flagship project over there. There was 18,000 holes to do in the tunnel, all overhead drilling. The D3 model, this is the D2. We've now upgraded it to the D3. It's a overhead drilling, hole cleaning, and anchor installation robot. So it actually takes on all three tasks. The layout option will come, but we wanted to stick to actually what was hazardous. So, you know, cost savings in that side of the world are very different to here. The labour is a lot cheaper. So I understand here a massive cost saving would be if it can do the layout, the drilling, and the hole cleaning. That will be the next step. But with regard to this, we clean the hole. We used, I think it was 10 mil by 57 wedge anchors. So it will, it can autonomously drill the hole, clean the hole, and then install the wedge anchor. Same model, the D3 was also used in a logistics centre. So obviously you can see here, prime example of working at heights. We've removed the operator from the high risk task. We've removed him from drilling overhead. We've removed him from any kind of silica dust exposure as well. And the operator there is on the ground, just kind of monitoring. So everything's kind of pre-programmed into the tablet. As long as it's in the working area of 2.5 meters, it will drill and find the holes using AI. It will auto recognize where it needs to drill, and it will undertake those tasks. And then finally, in Singapore, this was Bulim Square. This was a multi-story kind of high-rise complex. Very similar application, but this was for the cable containment, 12 mil by 72, and exactly the same. Drill the hole, clean the hole, and install the anchors. As you can imagine, in the future now, automation is becoming a big thing, and major projects like HS2, for example, who we're working with now, they embed automation and robotics into their procurement tenders. So anything that they're winning the business on, they now have to bring a robotic solution for those high-risk tasks. Not only can they not get the labour, but they want to automate the drilling in a tunnel. So we've got a couple of projects coming up now that I'm really excited about with HS2, with Costain, and the joint ventures with Vinci and Balfour Beatty, which will be, they've got 13 tunnels, one of which has got 64,000 holes for the lighting, and also some cable mounting on the side, which is going to be about 80,000 holes as well. So the prime example of this would be horizontal drilling using the D3. We're going to have live scenarios from, say, March, April next year, ready for 2027 deployment. And the desired outcome on one tunnel will be two gangs, a north and a south, and they'll have 2 robots in each, and they'll both be working through the night. So hopefully we can speed up the HS2 delivery plan. Any questions? Let me know. Are we going on time?